So in this second video, I will introduce the theoretical aspect which are compulsory to understand before creating the actual project. So UART stands for Universal Asynchronous Receiver and Transmitter. It is a serial communication protocol that sends parallel data in a serial and asynchronous way. Serially here means data being transferred bit by bit, that is, one after the other, compared to parallel transmission where all data bits are transferred at once. Asynchronous means that the receiver and the transmitter do not share a common clock, that is, they are not being synchronized compared to other synchronous transmission like SPI, as we'll see in another tutorial. It is also known as serial port, COM port, or RS-232. To configure UART, some parameters need to be configured first. The first one is the baud rate. This is the number of bits sent per second. Both transmission and receiver will agree at the rate of data bits to be sent per second. Standard baud rates include 300 bits per second, 1200 bits per second, 2400 bits per second, 4800 bits per second, 9600 bits per second, 19200 bits per second, 38400 bits per second, 576 bits per second, and 11500 bits per second. The second one is the parity bit. This parity bit, we use it to check for single bit error or error of odd numbers of bits. It is configured to either be on, that is, parity bit is transmitted, or 0, no parity bit is being transmitted. So from the diagram above, you can see the serial bits to be transmitted. You can see the location of the parity bit. You can also see location of the stop bit and the start bit. The line idling is conditions where the transmission is held high. Nothing happens at this stage. So the third one is the stop bit. This bit can also be configured to be either 1, 0, or 2, depending on what pattern of configuration you are using. But the stop bit for UART is usually a 1, high. That is, whenever the TS and the RS line is high, it means nothing is being transferred. And you can see here there is written line idling. So for it starts with a stop bit, which comes after data transmission. So next, the transmission can also be configured to be simplex. That is a situation where data is sent in only one direction, or half duplex, where data is being sent in both directions, but one at a time, or full duplex, where both can send and receive data simultaneously. So you can see the difference between half duplex and full duplex. In half duplex, one sends and after another sends. But in full duplex, they can be sending at the same time and receiving simultaneously. Then next, we have the number of data bits. The TX and the RS have to decide the size of each data frame, whether it's 7 or 8 bits, or maybe 16 bits, or maybe 32 bits, depending on the configuration or agreement.